Alright, so addition for functions is nothing but combining like terms. It's that simple. So I want you to put beside addition, combining like terms. That's all it is. And let's review what are like terms. They have to have the same what? Like terms. Not necessarily. Like, for example, I could add like 2x and 3x, right? They have to have the same what? Variable and exponent. Cool. Alright, subtraction is the same thing. You're combining like terms. The only difference is before you combine them, you have to change the signs of the second function. So like, you leave f the same. Say if we have this one. You leave x minus 1 the same. You just change all the signs before you combine them. So I'm going to write out to the side. Same as adding. Adding, except, change signs, bless you, of second function. So you're just combining like terms, but change all the signs of the second function before you combine them. What? Connor, will you do me a favor?
This one.
Oh, wait. Yeah, will you plug this in that plug over there? My cart plug doesn't work. Didn't reach. Oh wait, that's my speakers. Change that. This one. Thanks. Now we're cooking. Okay. Multiplication, y'all know how to multiply functions. The only thing I want to remind you of, if I have two binomials, what do I have to do to multiply them? Do y'all know what a binomial is? Good. Okay. So if you have two binomials like x plus 1, x minus 1, there's an example. These are binomials because they have two terms. Remember, you have to pull. That's the only thing I'll say about multiplication. Don't forget that. Now division is where it gets a little different. Okay, for division, setting it up is very easy. Whatever's on top, that function f, that's what you put on top. Whatever's on bottom, g, that's what you put on bottom. But after you set it up, the first thing you have to do, check if you can factor. And you'll see why in a minute. Check if you can factor. And the second thing you have to do when division is list the domain. And I know what you're thinking of. When you think domain, you think graphs, but we're not graphing. It's a little different. Alright, I think we're ready to get started. So on number 1 and 2, and for your homework, all we're doing today is they'll give you two functions, like f of x, g of x. We're going to add them, subtract them, multiply, and divide them. That's all. Alright, so we'll start with adding, the easiest ones. And again, adding just means you are combining like terms. So tell me two like terms in these functions. Y'all being so quiet this morning. Alright, go ahead.
-1 and -2.
Yes. Alright, -1 and -2, if we combine them, that'll give us what? Yes. Do we need to write that first or last? Go ahead. Last. So I'll write -3 over here. So we've combined these. Aren't these like terms as well? When we combine them, we'll get what? Very good. So f plus g of x is 6x minus 3. That's all. You just combine those like terms. Alright, subtraction. It's the same thing, except you're going to change all the signs of this second function. So the f terms, x minus 1, I can leave the same. But for g, I need to change these signs. So instead of 5x, it'll be what? And?
2.
Yes, plus 2. And then after you do that, you change the signs, you just combine like terms. So, Rihanna, tell me two like terms that you see.
X and -5.
when we combine them? Good. Darius, tell me the other two terms you see. So when we combine them? Good. That's it. So f minus g of x is negative 4x plus 1. That's all it is for adding and subtracting functions. Very simple. The next one is multiplying. And I want to point out this one thing. It'll come in handy tomorrow. I know it seems silly right now. But notice how f times g of x, that this circle right here is closed in for multiplication. Sometimes you'll see it open where it looks like fog. That means something completely different. When it's closed in circle, that means multiply. Might want to write that down. Multiply when it's closed in. Alright, question also. Does it matter what order I write these functions in when I multiply? No. Very good. So you could write any of them first. I'm just going to write the f function first. And how do we multiply these? Yes, because there's two binomials. So Toby, tell me the first two terms, or the first terms when I multiply them. Bless you. Good. Alright, Simon, tell me the outer terms. Very good. Caleb, inside terms. Very good. Julia, last terms. Very good. Alright, can I leave my answer like this? We can combine what terms? And that would make, very good. So f times g of x is 5x squared minus 7x plus 2. Alright, and like I said, this should be a review. Nothing new we're learning here. Hopefully y'all remembered how to do that. Division's a little different. I'll go over here. So f over g of x. The setting up part is easy. What goes on top? Or, yeah, does it matter what order when we do division? Yes. Like, for example, what's 6 divided by 2? What's 2 divided by 6? 1/3. See how they're different? So it matters the order when you're dividing. So f has to go on top, which is x minus 1, and on bottom has to be g, which is 5x minus 2. Alright, first thing, I'm going to come back up here. Check if you can factor. And we need to check if we can factor them separately. So this top part, x minus 1, can I factor that? Nope. They don't have anything in common. It's not difference of squares, sum of cubes, all that good stuff. Can I factor this one? Nope, they don't have anything in common either. So I've checked that, can't factor. Now for the domain. We have to list this because with fractions, what cannot be on bottom of a fraction? Negative what? Correct. What else? You can have a variable on bottom. You can't have what on bottom of a fraction? Y'all know this. 0. Right? You can't have 0 on bottom of a fraction because can you divide numbers by 0? No, it would be undefined. So we have to figure out, okay, what number could I plug in for x that would make the bottom 0? Okay? So how do you think we could find that? How do you think we could find something to plug in here that would give you 0 on the bottom? I can't tell if y'all being quiet or y'all just really don't know. Alright, well you set the bottom equal to 0. 5x minus 2 equal to 0. And then you solve for x. So how would we do that here? Add 2, good. And then what? Very good. So x is what? 2/5. That means if we were to plug 2 over 5 in for x right here, that would give us 2. 2 over 5 times 5 is 2. Minus 2 would be 0. Does everybody see that? So the domain, how you write it, you just write comma, x cannot equal 2 over 5. Because if it did, the bottom would be 0. That's a no-no. Can't divide by 0. So that's what I mean by list the domain. X cannot be 2 over 5. That's it. Alright, questions about adding, just combining like terms, subtracting, multiplying, or dividing? We're going to do one more together, then you're going to do some on your own. Alright, starting with f plus g of x. Combining like terms. I don't have to write that out, I don't think. Amy, tell me what the first term would be after I combine them. Good. Alright, Catherine, what would the next one be? Perfect. There's nothing to combine it with, so you just bring it over. And then, Nikki, what would my last term be?
0.
Good. But do I have to write it? No. I'll just leave it like that. So that's f plus g. Alright, f minus g. I just have to change the signs of which function? Yes, so I'm going to leave f the same. 3x squared minus 4. Connor, tell me how to write all of this. Oops. Down here when we're subtracting.
Negative x squared plus 8x minus 4.
Very good. Alright, William, tell me my first terms after I combine them in the correct order.
2x.
Good. 2x. Good. So I combine these. Madison, my next one.
Plus 8x.
Perfect. Sid, my last one.
Minus 8.
Very good. Any questions on that? Alright, moving on to multiplication. F times g of x. I'm just going to write f first, so 3x squared minus 4 times x squared minus 8x plus 4. Alright, how would I multiply these? Would I use the full method? Why? Correct, so how do I multiply? Distribute. Good. Distribute 3x squared first. So, Bryant, what would my first term be?
3x to the 4.
Very good. Alright, Abigail on. My next one.
Negative 24x cubed.
Very good. Alright, Sawyer, my next one.
12x.
Good. Alright, Alex, my next one.
Negative 4x.
Good. Moving on to distributing the negative 4 to all terms, so negative 4x squared. Alright, Marillion, my next one. Very good. Amy, my last one.
Plus 16.
Try one more time.
Plus negative 16.
Yes, or just minus 16 instead of plus negative. Alright, now all we have to do is combine like terms. Alright, Abigail Canada, what's my first term going to be?
3x to the 4.
Good. Alright, Brandon, my next term.
Negative 24x.
Very good. Darius, my next term.
Plus 8x.
Good. Nicole
32x.
and Hope.
Negative
Very good. That's it. Questions about that one? So if they don't have anything to combine with, you just bring it on down. Alright, moving on to division. So f over g of x. What goes on top? Good. And before we move on to the bottom, let's look at this one. Can we factor this? Alright, I hear yes. The squared and the 4 makes you think like difference of squares. Y'all remember that? But why can't we use difference of squares?
The 3.
Yes, the 3. And do they have anything in common? So we can't factor it. So let's move on to the bottom. X squared minus 8x plus 4. Can we factor the bottom? Alright, tell me why.
Because 4 doesn't have an x in.
That would be if you're trying to do GCF, correct? So we can't do GCF. Could we do AC easy? Why? Good. Everybody here? There's no factors of 4 that could add to be negative 8. So we can't factor either one. Now we check for the domain. which we're trying to figure out what can we plug into x to make the bottom equal 0. So we set the bottom equal to 0. X squared minus 8x plus 4 equals 0, and we're solving for x. So how would I do that here? We could subtract 4. I don't think that's going to help us. We can't factor it. Yes, very good. So smart. Okay, quadratic formula. Do y'all remember that? I don't need to sing it, do I?
You do.
I do? Okay, y'all are going to have to sing it with me. Are you ready? Okay. Alright, we'll sing it one time and then we'll move on. Alright, repeat after me. Negative b
Negative b
plus or minus square root
plus or minus square root
b squared minus 4ac
b squared minus 4ac
all over 2a.
all over 2a.
Cool, everybody remembers it. Alright, so let's start with, we don't need to write it down, do we? Okay. So negative b, the first thing we'll have is what? Plus or minus what? Of? Yes. But how do we get 16? We had to do 4 times a times c, which is 4 times 1 times 4. Good. All over 2. Alright. So Toby mentioned this is 16. That's correct. What's 64 minus 16? 48. Alright, before we move on, if you're doing a problem like this, and let's say you have a negative number under here, that means that you'll have a what involved? Imaginary. So if you're doing this to find the domain, I want you to know domain is only dealing with real numbers. So if you get a negative number, you can stop. It won't have a domain, okay? But this is not. It does have a positive number. So how can we simplify this? 4 times 12. Yes. Doesn't 12 have a perfect square in it? Yes. So think of a bigger square than 4 that can go into 48. How many times?
3.
Good. Oops. Alright. From here we can take out what? 4. Good. What's underneath? 3. On bottom? If my favorite pen goes out, I'm going to cry. Alright, can we simplify this? Yes, what goes into all of them? So I'm going to go up here and go ahead and write comma, x cannot be, because we're about to have our final answer. X cannot be what right here? 4 plus or minus. Square we go. Very good. So that was the division one. On your homework, I don't think I gave you any quadratic formula ones. Any questions about these two problems? Alright, if you look at the back, it has to do with composing functions, which is learning target 3, which means we're going to be working on that tomorrow. What I want you to look at is this sheet. It says study guide, but it's not a study guide. Can I borrow yours for a second? It's your homework, and for your homework it's just 5 problems, but we're going to look at number 1 together because I want you to do one on your own to make sure we know what we're doing, and then I'll let you work on the rest of them on your own. But for each one you're going to have to add them, subtract them, multiply and divide. So obviously you can't do it on this sheet of paper, you won't have room. You can work on the back or on a separate sheet of paper. Don't forget this is due tomorrow, okay? But what I want you to do now is work on number 1. Feel free to work with a partner if you want to. We're going to work number 1 together, go over it, and then I'll let you work some more on your own, okay? Thank you.